Welcome back to D-Electric. We're going to look at some supersized motors this week. We have several of them. I'm sure you saw on the flyer around we're pretty full, but it's mostly with bigger stuff. So let's go see what we have. Okay, so this one we have here is a 2,000 horsepower, 3,600 RPM motor. It is a sleeve bearing motor. We discussed sleeve bearing motors before, but it's a sleeve bearing motor. Therefore, you can see where you have the front blocked. We always block the front of them so the shaft can't move during shipping. So we also, this one's a spare for this particular customer, so you can see the wood on top. Normally that air end or what we call a doghouse would go on top of here, but they store it separately. So this is actually complete. Obviously you can see it's painted a pretty red color, and we're going to be actually shipping this tomorrow. So this is complete and ready to go back. Just wanted to get a shot of it because it's one we just overhauled. And this was just an overhaul, no winding work or anything like that. It was just in service for a while. The customer wanted it overhauled. So there you have it. Okay, keeping with our super motor theme, this is a large generator. It is a brushless DC generator, and I'll show you what the brushless means in a minute here, but this is 2,800 kW, and again, it's a generator, not a motor. So this is the driven end. Something drives this to create the power, and that's what generates. So you can see on this one it's dirty. This one's just coming apart. We have a second one that's been apart and cleaned. We're going to look at that in a minute. But I wanted to show you this one first, so it's early stages of disassembly. And you can see how dirty it is. We expect this just to be an overhaul, but we won't know until we're done. So let's go around to the other side and look at the other side of the motor where the exciter mounts. And that mounts on the end of the shaft here is where the exciter would mount. So I mentioned it's a brushless DC motor. So a lot of DC exciters, so a lot of exciters have brushes on them and rotating parts you have to worry about. This does not. It's brushless. So again, you can see we're just starting to disassemble this one. And what mounts on here, the exciter I'm talking about, is right over here. And as you can see, this part here will mount on that shaft that we were just looking at, and then this gets mounted around the outside of it. And as you can see, there's no brush holders or no rings or anything. That's why it's brushless. The end of the shaft has the wires coming out that connect to that, and that's what excites the rotor in order to start producing the energy. So that's the components we have here. We have the other one apart. We're going to look at some of those components as well. All right, so the large generator we just looked at, this is the second one we have here. They're both the same size. They're out of the same plant. This one's been apart and cleaned right now, so we're in the process of checking it. And as you can see, the rotor has a wound rotor on it. The wires come out through the center. And this would be where that exciter we just looked at mounts, and this connects to that. And so there are no brushes. Everything is just connected, and it rotates with the rotating assembly. This motor also happens to be a sleeve bearing motor, as was the red one we saw earlier. So it has the sleeve bearings like this on it with the babbitt on the inside, and that's what sits on this part of the shaft right here. So this particular motor, or generator, I'm sorry, is sleeve bearing, as well as the other generator and the red motor we looked at a little bit earlier, the 2000. They're all sleeve bearing motors. Okay, so to look at the stator on the generators we were just looking at, we have to go to the oven. This one's baking right now. I just turned it off, and we're going to open it up. And inside you'll see the stator that belongs to those generators. This has been in the oven baking for about 12 hours. It just finished, so it's going to have to get brought out, cooled down, and then all the electrical tests being done. Okay, we have a 500 horsepower, 1,800 RPM motor here. This is also one of two we have in the shop currently. So this is another one that has the large dog houses on top of it, but right now that's off. We're in front of the test panel here because we're getting ready to test run it. It measures good and all, so we're going to test run it before we take it apart. but this is actually out of a plant where, again, we have two of them. And again, they're supposed to be overhauls only. The customer had them running, they just want them going over. And again, we have sleeve bearing motors. So this is the third one we're looking at that actually has sleeve bearings on it. And we have a second one of these, like I said, and it's a part. So much like the generator we looked at, we're going to be able to go look at the separate components as well. This particular one also happens, you can't tell by this, but it's got a lot of RTDs and bearing heaters in. You can see all the wires inside here. That's what these all are, and that's what this large box is right here. It has bearing RTDs, it has winding RTDs, and it has heaters in it. So again, we're just in the testing stage, and then we'll be disassembling this. Okay, so the 500 that I just talked about that we looked at that we're getting ready to test run, this is the sister motor to that. As you can see, it's apart. This has been cleaned. The stator has been tested, so that's good. This is the rotor that goes with it, and this has been taken apart and checked. However, this rotor has cracks in it. So this is going to need to be quoted to have this rotor rebarred. There's cracks in the rotor over here. I don't know how well you can see them, but that can't happen. That causes a lot of heat. You can actually see a little bit of heat right here on the rotor from the crack that's in there. And there's multiple cracks on here. It's just one that I pulled around to show. So outside of that, this is going to need that, but the stator is okay. But these are the components out of that motor. Again, it's an identical motor. There's two of them. Okay, so staying along our theme of large, I wouldn't call this supersized. We've done larger gearboxes, but it's a pretty good sized gearbox. So we just wanted to take a look at this today too. So this gearbox is about 85% complete. You can see the stuff sitting down there is the old bearings and seals that came out. The inside of this is already done. We have some photos of that you'll see here of the inside, the gears. It looks good on the inside. The outside obviously hasn't been painted yet, so it doesn't look like a repaired gearbox yet. And that's very important when we do that. We paint everything because you do all that work in there. You want to make sure it looks good when it's done, which is what we do here and at Reading and at all our shops. So that's what this one is, a large gearbox, all but done. Just need to button it up, the top of it here with the input, and then once that's done, we'll put a paint job on it. It will be ready to go. All right, so this one is a 450 horsepower vertical motor, so the whole motor stands vertical. This is the stator. This one happens to be a rewind. This blue in the winding, so it has to be rewound. The rotor back here, as you can see, this is a hollow shaft, which is very typical for vertical motors. They stand upright. And on this particular one, there's components here, but on this particular one, I wanted to point out the bearing carrier. This is actually the bearing carrier that goes on top of the unit. And there's a lot of damage on that. That was, I don't know that caused the problem, but it had been in service for a while and there was a lot of degradation on that. That's actually an insulated area, so that the top bearing is insulated on this motor. So that needs to be replaced and it needs to be rewound. So, and again, this is a vertical motor. When it's done, it'll stand in a vertical position. Hey, thanks for stopping by D Electric. Glad you could come by again to see our supersized motors and our gearbox that we looked at, and also with the flyover. Hopefully you got to see some of the stuff that we had in the shop. It's pretty busy, but like I said, it's bigger stuff. So let's go see what Reading has to offer. Hope everybody has a Merry Christmas and a Happy New Year. See you later.
Welcome to Reading BDS. Let's see what's going on. Here's a Russ job. Let me introduce you to Russ Yerger, our service manager.
Hi, here we have a fire truck that came out from a local fire company. It is a power takeoff driven unit made by Onan, and we had to remove the generator to do warranty repairs. Once we removed the generator, we tested it inside the building. Now we're ready to put it back inside. In the truck, the guys will connect the PTO, and then we'll do our testing to verify operation. Thanks for taking the time to take a look at what we do with backup power generation on a fire truck. And now I'm going to turn you over to John Eckert.
Okay, I'm just going to show some of the jobs we have in the shop that are not looked at yet. So just go over them a little bit what we have here. This is a SEW motor. As you can see, the shaft is broken off it. So mechanics will take it back, we'll rip it apart, check everything out, then we'll quote on either making a new shaft or stubbing this shaft, and also obviously get a price from SEW to see if it's cheaper to replace it than repair it. Next two units in the shop here, these are Onan generators. They're driven by power takeoff. These are usually on scrap magnets, cranes, or fire trucks. As you saw outside, some of them, they are driven off the drive shaft, power takeoff. Get these in the shop, we'll take them apart, do all the electrical tests on them, and the voltage regulators and so on, mechanically, bearings and so on. Everything checks out okay, we'll put them back together, and then we have a test rig where we'll actually put a pulley on, driven by a DC motor, to run them at full RPMs to make sure they put out the proper voltage that they're supposed to, and also put a load on them to load them up. Next units here, these are submersible pumps. As you can see, they'll be again taken apart, checked out, all the bearing surfaces and so on will be mic'd. These are explosion proof, so we have to go through the UL relisting, check all the clearances and the surfaces, make sure they're smooth to be sealed against explosion. Then it'll be quoted, check the cords out, bearings, seals, so on. Work up a quote and quote the customer. Okay, what we have here is a large gearbox. This is just in for general service. It's supposed to be okay other than bearings and seals. So again, we'll take it apart, mic all the surfaces and journals, and quote the customer on replacing the bearings and the seals, whatever else needs to be repaired on it. Okay, this will be checked by our welder department. Usually what we try to do is get an answer from the customer what problem they're experiencing with a welder, and then it'll give us something to look at because there's so many components in these units. It'll get back tested, and again, once it's repaired after the quote, we will put them on a load bank and load test them, make sure they have full output. Actually even do some test welding with them. Okay, these units are in water pumps. What we'll do, we check these out. As you can see, these are pretty well rusted, probably from the chlorine in the water. You can see the bases are very rusted here. So this motor will probably be replaced. One thing you have to be careful when the base is welded or rusted away like this, it won't set flat on the base. So if we would just clean this up and give it back to the customer, they tighten the bolts down to bolt it down. It'll actually twist the frame of the motor, and it'll preload the bearings. So again, that motor will probably be replaced, but we'll sandblast the pump parts, clean them up, new seal gaskets. Also, another thing we do here at Reading is the impellers, as you can see, it's very rusted, cast iron. We have a product called Enicon Ceramaloy. What we can do is we'll sandblast this impeller and put a coating on it, two different coatings, two different colors, so you can see if it's wearing off. Coat the impellers, this will make it nice and smooth. It's like an epoxy coating. It also increases the efficiency of the pump because the water goes over the impeller when it's a smooth surface as opposed to a pitted rough surface. So it increases the efficiency of the pump and also keeps the impeller from rusting, which will make it last a lot longer. Okay, here's another water pump just like the other one, so I won't go over that. This here is a Getty DC motor. Again, it's a permanent magnet frame and also brushes and then tack and encoder. There's a tack on the back of these. So we'll take them apart, check the armature, probably turn undercut the commutator, check the tach generator to make sure it's putting out the proper voltage, quote the customer, again, of course, put it back together. Okay, here's another larger DC motor. This is just in for general service. Again, we'll test run it if it checks okay before we take it apart, make sure if we hear any mechanical noises or see anything, and then we will take it apart, check all the electrical parts, the fields, interpoles, armature, tack, and also, again, the bearing housings. Quote the customer, and it'll go through the shop, get reassembled, and fully tested then before it goes out the door. Okay, here's a DC field frame that we just rewound these shunt coils. As you can see, they weren't dipped yet. Basically, we took the old ones out and sandblasted the whole unit, put the interpoles back in because they were fine. Rewound 2 field coils, taped them, reinstalled them on the pole pieces, bolted them in, and next step, the leads were put on. Connections on this side, new leads out. And after this is done, it'll go back in the dip tank, which it'll get dipped and then baked overnight and be reassembled tomorrow morning. Okay, what we have here is it's an old Westinghouse contactor off a DC crane. Came in, what we did, we took it all apart, sandblasted everything, repainted it, made sure all the parts were back to specs and clean in operating condition. Also, here's the old coil. As you can see, it's shorted out. So basically what we have to do, we had to make a new form, wound a new coil, taped it, we put air dry varnish on it, new leads. That'll get installed over this armature piece here and get reassembled and go back to the customer. This part is obsolete. You can't get the coil anymore, you can't get the whole contactor, so they're hard to come by. So that's why it's being repaired.
Thank you for visiting D Electric and Reading BDS. We hope to see you again soon.